Today we're going to talk about something called Hess's Law, which is how we take multiple chemical reactions and make them thermochemically equivalent to a single reaction. This is going to be our theoretical way of calculating enthalpy changes. So you need to be able to describe how Hess's Law functions and use it to determine enthalpies. So as you might expect, Hess's Law is named after a guy named Hess, Germain Henry Hess, who was a Swiss-born Russian chemist and physicist. And what he found is something we call Hess's Law. So Hess's Law allows us to predict enthalpy changes. And Hess suggested in the 1840s that the addition of chemical reactions, like you can do a chemical reaction in steps, start from the two products, and you could go just one way over into the final reactants, or you could do a couple of intermediary reactions to get to the same place. And Hess suggested that, well, if we can do a couple of different reactions to get to the same place chemically, that must also mean we can do the same thing thermodynamically. If we add all of the chemical reactions that are intermediary steps together, we will get the same enthalpy as the overall reaction. The way that we write this mathematically is with delta H is equal to the sum of all the equivalent delta H's. So the set of reactions that is different steps, but the initial reactants and the final products are the same, then the enthalpies of all of those reactions combined together will also be the same. And this is super important because it meant that Hess could do enthalpy calculations without having to do calorimetry if he knew the enthalpies of the reactions. And in fact, this is what allows us to do enthalpy reactions to predict what the enthalpy of a reaction will be without actually doing the calorimetry calculations, as long as we have all of the prerequisite knowledge. And we can visually represent it this way. The enthalpy difference between this reaction is the same as the enthalpies of these two reactions. So we have an unknown here. Well, we could actually figure out this unknown by looking at the enthalpy of the overall reaction and taking away the enthalpy of this step right here. That's the basics of Hess's Law.